In the last few videos in this series, we broke down how containers actually work. We saw namespaces for isolation, we built our own environment and even replaced the root file system. So at this point, you might be thinking this is actually a container already. But there is one big problem. Nothing is controlling the resources and that changes everything. So stop thinking containers are safe by default because they are not. So for example, if I run a simple command like this, now watch this. This one process is taking almost all the CPU and nothing is stopping it. Now if I apply a limit and I run the same command again, now it's controlled, same process but different behavior. And if I push memory beyond the limit, it just gets killed. So no Docker, no Kubernetes, just Linux. So what changed? That is Cgroups. So in this video, I will show you how Linux actually controls CPU and memory and why this is the piece that makes container reliable. So let's break it down. Let's start with the problem right now. Linux does not limit processes by default. So let me show you. So if I run yes and /dev/null. So what this command does, it just keeps printing forever and burns your CPU. Let's press enter here. So right now this command is running at the backend and utilizing your CPU. Now I will switch to the another terminal and I want to see the utilization of the CPU of this particular system. So for that I can use a top command. So top. Now look at the one process and almost 100 CPU is being utilized by that particular command itself. And if you see, it's around 97% and nothing is stopping it. No limits, no control. That's a problem. Linux can isolate processes, but it does not control how much they use. So how does Linux fix this? Using Cgroups. Now think of it like this. Instead of controlling processes one by one, Linux puts them into groups like folders. So if you see this particular box, this is a Cgroup. Now look here. We have two sections, like one is a CPU usage and another is of memory usage. And CPU usage is of 50%, that is maximum. And memory limit is of 100 MB, that is also maximum. And these limits are applied to the whole group. And if you see below, multiple processes are running inside it. And it doesn't matter if it's bash, system utility or a Python. All of them share the same limit. That's the key idea here. Linux does not control processes individually. It controls the group. So instead of chases every process, you just control one Cgroup and automatically everything inside follow the rules. And this is exactly how container manage resources. It's not a magic, just Cgroups doing their job. Now this idea isn't new. Linux had Cgroups for a long time, but the first version had a big problem. In Cgroup v1, everything was separated. Like CPU is here, memory is here and IO is here. But they all are having separate hierarchies. Basically like having 5 different control planes for one machine. Imagine this, you want to limit a container. So first of all, you go to the CPU, that is one directory, then memory, another directory, and IO somewhere else. And now you have to keep everything in sync as well. That's not a fun and definitely not scalable. So Linux fixed this with the Cgroups v2. So in Cgroup v2, now everything is unified and one system controlling everything. One system, one hierarchy and one way to control everything. And that's why modern container prefers Cgroup v2. Alright, enough theory for today. Let's actually control the processes, and this is where things get interesting as well. First, let's see what system we are on. So for that we can use mount command to see which type of Cgroup we are running on this system. So if I run mount and grep for Cgroup in this. So as you can see, we have a type that is Cgroup 2. That means we are using Cgroup v2, a single unified system, exactly what modern containers use. Now let's look at how it's structured. For that we can inspect the directory. So ls, sys, fs and Cgroup. So if you notice here, no separate CPU or memory folders. Everything is in one place and controls happen through files like cpu.max and memory.max. That's a big shift in the Cgroup v2. One unified system controlling everything. So before creating our own Cgroups, there's one small catch. In Cgroup v2, nothing is enabled by default. So if we see what controllers we can control in this particular system, we can look for a file that is cat sys fs cgroup and cgroup.controllers. So this shows what we can control: CPU, memory, IO and many more. Available doesn't mean it's enabled. Right now none of these are active for child Cgroups. So we have to enable them. So for that we can use command that is echo and plus CPU plus memory, and I'm going to put it under the file that is sys fs cgroups dot subtree underscore control. Now let's press enter here. Now CPU and memory control are turned on, which means any C group we create can actually enforce limits. Think of it like permissions. Until you enable it, your C group can't control anything. So just now we enabled the CPU and memory only in the C groups. Now let's create our first C group. So for that we can create one directory under the C group folder. So mkdir sys fs C group and demo underscore v2. So the directory got created. So this creates a new control group. Right now it has no limits, no processes. It's just an empty container for control. So now let's define these rules. So for that I'm going to use a echo command. So echo 50,000 and 100,000. And I'm going to put it under the file that is sys fs C group demo v2, the folder which we created. Under that we are going to put it under the file that is cpu.max. So what are these values? The two values, which is a quota and the period. So 100,000 means total time to window, that is 100 ms, and the 50,000 is how much CPU time this group can use. So out of 100 ms it can run for 50 ms, which means 50% CPU limit. And after that this process is paused until the next cycle. So Linux is basically doing controlled scheduling. So let's press enter here. So we have set the limit for the CPU. Now it's time to define the rule for the memory as well. But memory works very differently. So first of all, let's create a file similar to the CPU as well. So for that we can use echo 100m and I'm going to put it under the file that is sys fs C group demo v2 and memory.max. So this one is very simpler. The max memory is 100 MB. So no percentages, no cycles, just a hard limit. So let's press enter here. So if I see the content for the theme, so if you look at this particular number in this file, this looks very big, but it's just a bytes. So 10485760, that's 100 MB. So our limit is working. But this particular limit is a hard limit, and here's the key difference. CPU is slowed down, but memory is strictly enforced. So if a process crosses the limit, it gets killed. Now we need to put a process inside this C group, because by default C group doesn't control anything and we have to place processes inside manually. So for that we need to run this command that is echo $$ and under the file that is sys fs C group demo v2, and we are going to create one file that is cgroup.procs. So if I cat this particular file, so if you see, these are the process ID. So what this does, it puts this shell inside the C group. So now on, anything I run from here will follow those limits. So now let's test the CPU utilization, like how it's working now. So for that I'm going to run the same command that is yes, and going to put it under the /dev/null. So it's running right now, and let's clear out the screen here and run the top command again. So if you see, this process is running, that is yes, but the CPU utilization is around 50 only, and it's not able to exceed beyond that. So that means CPU is limited. Same process but different control right now. Now it's time to test the memory as well. Instead of using stress tool, I will use a real memory allocation. So for that I'm going to use this command. So let me cancel this first and clear out the screen. And let's run this command. So what I'm doing here, so I'm writing 200 MB into a memory, but our limit is 100 MB. So let's press enter here. So what happens here? It fails because memory isn't throttled like CPU. It's enforced. If you cross the limit, the process gets killed. So if you notice, the process gets killed, and in my case even the terminal session died because the shell itself was inside the C group. That's how strict memory limits are. No slowdown, just kill the process. But if you see on another terminal, this particular process is running. That is a top command. And if I cancel this, I can run multiple commands here. But this particular shell got terminated. Now let's take everything we built and turn it into a real container. So in previous video, we used namespaces for isolation and pivot root for file system. Now we add a control. So now let's reconnect with it. So I am going to create a container using the unshare command. Unshare --mount --pid --fork and bash. So this command creates a container like environment. So let's verify the same. So echo $$ So PID1, that means we are inside our container. Now let's configure the C group. So for that we are going to create a directory. So I'm going to copy paste the command which I used earlier. So first of all, I am going to create a demo container directory under the C group directory itself. So let's press enter. So now I'm going to add this current shell into the C group. So for that I'm going to use echo $$ and I'm going to put it under the /sys/fs/cgroup/demo container which we just created, and then cgroup.procs. So now this particular shell has been added into the C group. Now it's time to set the policy for the CPU and memory. So for that I am going to copy paste the same command again. So this time I'm adding a 30% limit to the CPU and I'm going to put it under the cpu.max file only. Let's press enter. So the CPU limit got added. Now let's add the policy for the memory as well. So let's run this command. So this time I'm adding a 50 MB limit to the memory as well. So let's press enter. Now we have added both the limits, that is CPU and memory, to our C groups. Now it's time to test the same. So for that I'm going to use a yum command. So yum install curl. Let's press enter here. If you see, it got killed because this particular process is taking memory above the 50 MB. So that's why it got killed, because memory just killed the process. And this is exactly how containers work. If you ever seen a pod getting out of memory killed in Kubernetes, this is exactly what's happening underneath. C group is the one who applies those limits to that resources. Now let's connect everything. A container is just a process with namespaces, its own file system and resource control. Nothing's magical, just Linux primitive working together. So now you have seen container don't control resources, but Linux does using C groups. But there is one piece still missing, that is networking. So how containers actually talk and how things break in a real system, that we are going to cover in upcoming videos. So if you found this video helpful, hit like, share it with your friends and subscribe for more content like this. Thanks for watching. I will see you in the next one.